Every bank statement you read, every business dashboard you see, every analytics report that your company runs, none of that data arrived clean and ready automatically. Something had to pull it, clean it, and put it in the right place. That something has a name. It is called extract, transform, and load. It extracts the data from the source, transform the data in a human readable and presentable format, then push it to the destination. And let us understand why are we talking about the extract, transform, and load steps, right? So the pipeline architecture is interpreted as these steps. So basically, what does the pipeline mean in simple words, right? There is a step and there is a pipe and there is a step and there is a pipe, right? So this is a pipeline. Or if we can draw it like this, makes more sense. This is one step, pipeline, another step, pipeline, and next step, right? Something like this. This is a pipeline. Now, what we implement as part of pipeline architecture, where do we use this, right? So for layered architecture, we use the banking application, right? Each layer was doing one specific thing, right? Presentation layer, there was business layer, there was data access layer, and there was database layer. Same way, pipeline architecture it has two main components. That is the processing step and this is request passing, right? There is a processing step and there is data passing step. So in architectural word, this processing step is called filter, filter. And this passing step is called pipe. Now, observe what is happening at every step, right? So, if you take filter one, say, right? What it is doing is extract extract the data from the source, right? Transform or process the data and load, right? Or push to next step, right? It can be anything. Next step can be anything. And the previous step can also be anything. But at every given step, this is what is happening. Take the data from the source. Maybe it can be filter 0, right? Take the data from filter 0 and processing. Filter 1 processes the data, transform the data, then pass it to the filter 2, right? Okay. Extracts that. What exactly is happening? It pulls the raw data from any source. It can be a database, it can be an API, a CSV file, a cloud storage bucket, anything. You're simply reading and collecting the data exactly as it is from the source. No changes applied it, right? Just the collection of all the data. Now, at transform step, this is where the real work happens. What it does, it cleans the data, removes any duplicates, fix formats, right? Convert formats, maybe from JSON to XML, XML to JSON, right? Any other format, and join all of the data back from multiple sources, apply business rule if required. Basically, take raw, messy data and shape it into exactly what the destination needs. That is the responsibility of transfer step. Now, loading the data. What it does, write that transform data clean into the system. Usually a data warehouse, a reporting database, or an analytic platform where business systems can query and analyze it, pushing the cleaned and transformed data to the destination system. That is load step. Let us understand this with a real banking example. A bank has millions of transactions happening every day across multiple systems. There is core banking, credit cards, loans, UPI payments. All the services are running. Each service stores the data differently, different formats, different currencies, different timestamps. Right? Every night there is a ETL pipeline running. So extract filter. What extract filter does? Pulls all the transactions from all the systems for last 24 hours. It is a raw data and has different formats and everything dumped, right? Now, transform filter converts all amounts to standard currencies, removes duplicate entries, flags suspicious transactions for the fraud team, calculate account balances, joins customer data with transactions data. So every record has customer name attached. This is all happening in transform filter. What does the load filter do? It writes this clean, processed, joined data into the reporting database. Next morning, when a bank manager opens their dashboard, he can see total transactions for last 24 hours, filter by top categories, right? Can find out what are the suspicious transactions. Now, all of that data is cleaned, transformed, and organized, categorized. All of this comes from that ETL pipeline running silently in the background every night. So, in real world, every bank, every insurance company, or any e-commerce platform, any enterprise runs these steps exactly. Now, if you notice what has happened, extract is one filter, transform is one filter, load is one filter, right? load is another filter. Each one does exactly one job, only its job. Each one passes its output to the next pipeline. Here, no filter, no filter knows or cares about what happened before it or after it, how the data was handled in filter 1 or how it is going to be handled in filter 2. Each filter operates independently. In fact, it is testable on its own. There is no connection between filter 1 and 2. So this can be tested independently. This can be tested independently. Same here. So in summary, the pipeline architecture is implemented through ETL systems. This is why the pipeline architecture is mostly and commonly used in enterprises. Again, ETL is extract, transform, load. Three steps. And two pipelines joining those two, right? Wherever we have data moving from one system to another through predictable ordered steps, we have pipeline architecture. Another example can be CI/CD pipelines, right? Or Unix commands, or Apache proxy policies, right? Every policy run after the other. Every policy is independent of other. It just receives the request data from previous step, apply its own policy, and pass it to the next policy. Now, when someone mentions ETL in their next project, you understand not just what it is, what it does, but why it is designed the way it is, and what architectural decisions it follows. When there is ETL, there is a pipeline architecture. Thank you for your valuable time. This session is part of Software Architecture series. There are more topics covered in different sessions. Please take a look and we will see you in next session. Thank you.